Hello, I'm Professor N.B. Hulle from G.H. Raisoni Institute of Engineering and Technology. In this video, we will try to calculate current in the load resistance which is connected between the terminals A and B using superposition principle. And here, for the calculation of the current, the sources are more. That's why in place of using the reduction technique, I will use the direct inspection method. Here, we have, this is the loop 1 having the current I1, here is the loop 2 having the current I2, here is the loop 3 having its current I3. Now, the current in the branch AB, if we are calculating IAB, for this case, IAB, A to B is the current I2, A to B is the current I2, that's why its current will be I2 minus its current I3. Means here, in this case, every time, for case 1, for source 1, we have to calculate I2, I3. For case 2, source 2, we have to calculate again I2 dash, I3 dash. For source 3, we have to calculate I2 double dash, I3 double dash. For source 4, we have to calculate I2 triple dash and I3 triple dash. Means every time, if we are interested in this current, every time we have to calculate I2 and I3. Now here I will consider its case first. Now here its case first. I will consider its case first. Now here in case 1, we will consider the 40 volt source. By that time remaining all sources, this 2 volt source, this 8 volt source and this 8 volt source is replaced by its internal resistance. Means here, if we are calculating its matrix will be something like this, general matrix. This is R11, R12, this is R21, sorry, R13, this is R21, this is R22, it is R23, and finally it is R31, this is R32, and it is R33. Here we have to find out the matrix. We will focus first on these three resistances. That is R11, resistance of the first loop. This is first loop, 8 plus 2, that is 10. Diagonal elements are positive. R22, resistance of the second loop. That is 8 plus 2, 10 plus 3, 13. It is again positive. R33, that is resistance of the third loop. That is 8 plus 2, which is 10. Again it is positive. Then we will focus on the two resistances R12 and R21. Resistance which is common for the first and second loop, which is minus 8 here. This is again minus 8. Then we will calculate R31 and R13, which is a resistance common for the first and third loop, which is no resistance is common for the first and third loop. That's why its value will be 0. And this is again 0. Then resistance which is common for second and third loop, that is R23 or R32. Resistance which is common for the second and third loop, which is the 2 ohm, means it will be minus 2 and this is minus 2. This is resistance matrix. For case 1, its currents are I1, I2 and I3, which is equal to its constants. In the first case, we have considered only this 40 volt source. That's why all sources are not existing in the circuit. That's why if we are traveling with the direction of the current, the constant 1 will be plus 40, second constant 0, third constant 0. Yeah, this is the matrix. Now here in this case, we are interested in the two currents because we are interested to find IAB, that is I2 minus I3 for first case. Now here we are interested in IAB, that is I2. We will calculate I2 first and then we will calculate the I3 and then we will calculate the IAB for each case. We will do this calculation for the case number 1. Here again I am using the calculator. Here. I will enter the values. I will make it on. I will go to the mode. Again, equation 1, I will press, then unknowns 3, I will press 3, A1, it is 10, then is equal to B1 is minus 8, then put is equal to, then 0, put is equal to, then D1 which is 40, put is equal to A2, it is minus 8, then 13, then it is minus 2, then 0, then again 0, then minus 2. I am putting is equal to sign every time because that is the syntax of this calculator. Then 10 and D3 is again 0, which is equal to. Here I am not interested in I1, we are interested in I2 and I3. Here this is I1, that is here this will be XYZ, XYZ here, this is XYZ, means X I am not interested in Y, 5.16, this is 5.16 amperes. Then I3 which is 1.03, this is 1.03 amperes. Now IAB, I will calculate IAB which is 5.16, this is 5. I will come to the normal, then here it is I2 is 5.16, this is 5.16 minus 1.03 which is equal to 4.13, this is 4.13 amperes plus this is the current for case number 1. Then here if we are going for the case number 2, now look at case 2. In second case we will consider the 2 volt source. Here we will consider the 2 volt source. By that time remaining all sources are replaced by the respective internal resistors. This source is replaced by all sources. Now here its matrix will be something like this. Its matrix will be something like this. This is same, this is minus 8 which is again same. This is 0, minus 8, 13, minus 2, 0, minus 2 and 10. Because we are not changing anything. We are changing only the source. For case 2 we have considered only this source. Right. Then here I will name for the second source its current will be I1 dash, I2 dash and I3 dash. I will name these currents as this is I1 dash, I2 dash, I3 dash which is equal to. Now here what will be the first constant? If we are traveling with the direction of the current for the loop 1, we are traveling from positive to negative, which is minus 2. Right? This is minus 2. For loop 2, if we are traveling with the direction of the current, this source is not there in the loop. This current source is not there in the loop. This source is also not, because these are replaced. Now here it's internal resistance. Now here if we are traveling in this way for the clock, loop number 2, that is negative to positive, which is plus 2. Then for third loop there is no constant, which is 0. Now here again we are interested in I2 dash, I3 dash and IAB dash, which is equal to, because this current is I2 dash minus I3 dash, because I2 is downward and so on. If we are doing the similar calculations again here for this, I will enter in the calculators. I will make the entries in the calculator is equal to. I will come to the equation mode, then mode, so it is mode, then equation mode, 3 equations, A1, 10 again, minus 8, 0, minus 2, then minus 8, then 13, then minus 2, then plus 2, then 0, then minus 2, then 10, then 0. This is X, we are not interested. This is Y, which is I2 dash 0.06. This will be 0.06 amperes. I3 dash, which is 0.012 amperes. 0.01 amperes. Now resultant current 0.06 minus 0.01, that is 0.05 amperes. This is the current for case number 2. Similarly, if we are considering the case 3, this is the case 3. In third case, we will consider, this source we will replace by its internal resistance. Now case 3 we will consider the source of 8 volt. We will consider the 8 volt source, this 8 volt source. Now here in this case, if we are going by the matrix, this is 10, this is minus 8, this is 0, minus 8, 13, minus 2, this is again 0, minus 2 and 10. Now its current I will name it as I2, I1 double dash, I2 double dash and I3 double dash. Here these are the currents, I1 double dash, I2 double dash, I3 double dash, which is equal to, what is the constant? This is 0, first constant, because for the first loop there is no battery. For second loop we are traveling something like this, that is positive to negative. First constant 0, positive to negative, which is minus 8, and then for third there is no constant, because for the case 3 we have considered only 8 volt source. We have considered only the 8 volt source, only this source 8 volt, and all other sources are replaced by the respective internal instances. Now here in this case again we are interested in this current again. This current can be calculated by knowing the I2 and I3. That's why I2 double dash and I3 double dash in this case. This we are interested in I2 double dash and I3 double dash, which is equal to, that will give IAB double dash, which is equal to. Now here if we are doing the same calculation, already we have entered values. A1 is equal to 10, then minus 8, then 0, then D1 will be 0. I will enter 0. This is 0. Then it is minus 8, then plus 13, then minus 2, then it is minus 8. D3 is minus 8, which is again A3 is 0, then B3 is minus 2, then C3 is 10, then again this D3 is 0, which is equal to, this is X. We are not interested in I1, we are interested in I2, which is minus 1.29. This is minus 1.29 amperes. Then we are interested in Z, which is minus 0.25 amperes. Then here the IAB is nothing but it is I2 minus I3. I2 minus I3. This here in this case, if I am going for the normal mode, this is 1. Then here it is minus 1.29. This is minus 1.29. Then minus of minus, which is a plus, this is 0.25, which is equal to, this is minus 1.04 amperes is the current in the case number 3. This is the current in the case 3. Then we will consider its final case, which is case number 4. This is case 4. In this case again, case 4, we will consider, we will remove this source, we will consider the final source, which is 8 volt. Now everything will be the same here. Everything will be the same. This is 10, minus 8, then 0, then minus 8, 13, then minus 2, 0, minus 2, and it is 10. The currents will be here I1 triple dash, I2 triple dash, and I3 triple dash. Here these are the currents. It is I1 triple dash, it is I2 triple dash, and it is I3 triple dash, which is equal to the constants. Here first constant 0, second constant 0, then third constant. Here in this case it will be minus 8. And here in this case, if we are calculating the currents, I2 triple dash is equal to I3 triple dash is equal to, and IAB triple dash is equal to, IAB triple dash is equal to, if I am using the calculator here again, here I will select the mode and then I will go to the mode equation, then unknowns 3. In this case it is 10, then minus 8, then 0, then 0, then minus 8, then 13, then minus 2, then again 0, which is again 0, then minus 2, again 10, then minus 8. Here its value of the X we are not interested. Y, that is minus 0.25. Here it is minus 0.25. In this case it is minus 0.25. This will be minus 0.25 amperes. Then the next value will be, it is minus 0.85 amperes. And this value will be here. If I am coming to the normal mode, this is minus 0.25, then minus of minus, it is plus 0.85, which is equal to 0.6 amperes. And its final current will be the addition of the three currents, or addition of algebraic summation of the currents. This is first current, second current, this is third current, and it will be the final current. That's it. Thank you.